So let's continue problem 2, rigid body kinematics 1. Previous video we find out the common point properties, point C, and we have Vc equal to 200 millimeter per second going down. And when we have a common point, we jump to the next body, which is gear B, and which is we move from the point C properties to body properties of gear B. And it always, when you move to another body, you need to draw the Rafa stick if that body actually in Rafa motion. In this case, it's Rafa there. So draw the next Rafa stick for gear B. So B and the C now on the left side. So let's see here. And as we already see, we already find out Vc. So start with what is already known. So Vc going down. Vc equal to 200 millimeter per second. And we already know the CB here. Also know the C relative to B, which is the radius for the gear B, and that is 200 millimeter. So let's write down 200 millimeter. And here Vc going down. The omega of the gear B have to be consistent with Vc. And in this case, consistent mean counterclockwise. Omega gear B. Everyone see there. Okay. So that is the Rafa stick for Vc on gear B. So from point C properties, so we have Vc. Now we want to find out the body properties. In this case, the omega GB. So we have the equation. Oh, if you recall, Vc equal to omega R, or omega equal to Vc divided by the radius. In this case, we work on the body gear B. So we have it body GB. So work have to be on the same body between point and body properties. Omega of angular velocity of gear B is equal to velocity of point C divided by the radius of C relative to B, which is the center of the gear. So plug in Vc is 200 millimeter per second divided by radius C relative to B, which is 200 millimeter. So this is millimeter per second. This is millimeter. So cancel out. From that, we can have 1 radians per second, and it will be counterclockwise rotation, as you can see there. So that we have the body properties. Is that the question asked? No, not yet. The question asking, what is the upward velocity of the hook at t equal 2 seconds? We already deal with the 2 seconds here, so that we can find out the omega of the gear A is 4 radian per second clockwise in there already. So the upward velocity of hook, so that basically the point properties, velocity of the point and the hook, same as the velocity of point D on gear B. So as you can see, step first from body properties of gear A to point properties, common point C. And then when you find out the properties for common point C, move on the body property of the next body, gear B. And now you already have the body properties. The next step have to move to the point properties. So from body property of gear B, we just find out omega GB gear B to point property. In this case, the point D, point property D. And in D here, also same as point H, because the hook and the rope transition vertically, and in that motion it is a translation. So on the velocity, on acceleration, on that same body have to be the same. So with that we can start point D, and you can see on the same body gear B. So what is the distance? 100, the inner circle with the radius 100 millimeter there. So you can see point D is there, and from that we can extend the graphite stick for this body gear B at point D. We can have velocity D, because omega GB counterclockwise and the hook it go upward. So we have the VD, it will be go up. And we also have the radius of D relative to B equal to 100. Let's write down here so that we're not confuse the step. D relative to B equal to 100 millimeter, as I showed you a second earlier. So we have the omega, point body properties of the gear B. Then we can find out the point property VD. So from that we can have VD equal to omega radius, right? Omega GB of gear B times the radius. In this case, we talk about point D, so it have to be D relative to B. Keep that in mind. If we talk about point C, then radius is C relative to B, the center where the body rotate about, the graphite body rotate about, and this one is D relative to B. So when you have D, then it have to be D there. When you have C, then C have to be there. Keep that in mind. So from that, it equal to omega GB 1, RDB 100. And with that, we have 100 millimeter per second going up. And VH also equal to VD, which excuse me, which is equal to 100 millimeter per second going up. And that is the answer. That is the answer. That is the question asked. What is the upward velocity of the hook? And so, step, as you can see, and I received the response like how to show step I on from the first lesson, virtual lesson. So I show you step by step there. So keep that in mind when you do. Give point, go to body, then go to point. If give body, go to point, then go to body, another body in that process. So no shortcut to happiness. Again, have to be one step at a time. And also remember to ask yourself this question when you solve the rigid body kinematics problem. Does the problem give point or body, so that we know what we should do for the next step? How many rigid body on that problem? If there are 2 or more rigid body, where are or is the common points between the body in this problem? That is C and D, and you can see there C between gear A and gear B, and then D between B and the hook with the rope. Keep that in mind. And we also need to classify the motion It's very important. When you know the motion, you can know what is the draft stick should be. Also very careful about the direction of the alpha omegas. In this problem, they have the same direction. Both are clockwise. The previous problem 1, and you can see they are opposite. The omega of the Ferris wheel is counterclockwise, alpha is clockwise. In that case, the Ferris wheel is decelerating, reducing speed. That's why they are in opposite direction. So bottom line, alpha and omega don't have to be the same direction. Only the same direction when the body in accelerating. So with that, finish the problem 2 and also keep that few note when you solve for all the problem in future. Good luck.